we are done with the Helmholtz model in our previous class. But अब ये जो कुछ भी मॉडल है हेल्महोल्ट्ज मॉडल, इज इट द ओनली सिंगल मॉडल फॉर योर electrical double layer, or you can say EDL? So its answer is no, not at all. So how many models are there? Three models. From these three models we have learned one only model, and now the second and third model is named as Gouy-Chapman model, and the third model is known as Stern model. Which model? Stern model. So I'll tell you each and everything about the Gouy-Chapman model and your Stern model. But before that, let me just load you one slide to explain you a Gouy-Chapman model and the Stern model. But before that, just tell me what is mean by zeta potential, which we have learned in our Helmholtz model. Do you remember? Very good. It means that you are not learning anything. You are just switching on your mobile phones and wandering here and there. Yes, na? Good. Very good. It's a good thing. So, now let me continue with the point. I know you are not learning, and keep it up, because it will not going to give you any success. See, if you want to achieve any success now, that is nothing but you have to be honest, is it? So see, someone have texted potential difference between fixed layer and mobile layer. Okay, good. And now, good Kshitija, now here we are going to learn a Gouy-Chapman model. So, whatever this Gouy-Chapman model is there, what is that model? To explain this model, I have uploaded one slide which is right in front of you. So, अब ये जो कुछ भी मॉडल है ना, इस मॉडल में मतलब कि अब इसको समझने के लिए आप लोगों को पहले तो समझ में आना जरूरी है बात, और वो बात दूसरी तीसरी कुछ नहीं बल्कि ये है कि what is mean by Helmholtz model or Helmholtz Perrin model, or you can say Helmholtz parallel plate model. See, a Helmholtz model is considering one stationary state or one stationary layer and another one diffused layer, and in between both of these layers, whatever the potential difference is creating, that potential difference is known as zeta potential. Now guys, when you have this this means in the Helmholtz model one layer was, let me just take a pen to tell you, एक लेयर है जो फिक्स है, दूसरा लेयर है जो डिफ्यूज्ड है. अब इनमें जो कुछ भी डिफरेंस है, अब इसमें ना ये जो कुछ भी डिफरेंसेस है वो डिफरेंसेस को हम बोलते हैं जीटा पोटेंशियल, नो डाउट. अब ये जीटा पोटेंशियल तो हम पढ़ेंगे, मतलब क्या है क्या नहीं है ये हम नेक्स्ट सेम में पढ़ेंगे, या फिर नेक्स्ट इलेक्ट्रोकेमिस्ट्री के डेप्थ क्लासेस में पढ़ेंगे. बट सी, whatever this your zeta difference is there, this electrical double layer what is formed, whatever this electrical double layer is forming, this electrical double layer is having one potential difference which is known as zeta potential, but this is forming in between your station, sorry, this is forming in between your काय की mobile phase, sorry, stationary phase and mobile phase. So whatever this your whatever this your these two layers are there, these two layers are showing you the accumulation of ions towards your electrode. But as you are listening, as you are learning, listen very very carefully, huh? Whatever this Gouy-Chapman model is there, in this Gouy-Chapman model you are not considering now your electrode as, means the difference between this your stationary state and whatever the next diffused ions is there, that difference is getting increased, or you are increasing that difference, or you can say in these words, in the words, or you can say in another words, like जो कुछ भी हम पढ़ रहे थे हेल्महोल्ट्ज मॉडल में, क्या पढ़ रहे थे बेटा कि ये जो कुछ भी लेयर्स होते हैं तो हेल्महोल्ट्ज मॉडल में हम कंसीडर करते हैं ये these layers are quite rigid, but in Gouy-Chapman model you are not considering means what? Wait, let me tell you, ये जो लेयर है ये लेयर और आपके ये जो सॉल्वेटेड आयंस या फिर आयंस है तो these are having the difference in them, means the distance between them is larger, or you can say they are not in rigid state. I mean to say though they are non-rigid, they are not rigid, or you can say in another words they are non-rigid ions, means they can move easily and they have their differences in between that stationary stationary layer, you can say, as electrode, and your other ions are like in diffused ions. So whatever this difference is there, this difference, now, these ions are not interacting with each other very easily. These ions are not interacting with each other very easily as they were interacting in Helmholtz model. But in Gouy-Chapman model, they are not interacting very easily. Now, whatever this your diffused layer is here, this diffused layer is somehow far apart from your like your हेल्महोल्ट्ज मॉडल. बट अब ये जो कुछ भी आपके आयन्स है, अब ये आयन्स मतलब उनमें जो डिफरेंस सॉरी, अब इनमें जो कुछ भी डिफरेंस है तो ये डिफरेंस you can have these can have the thickness of your double layer, मतलब ये डिफरेंस आप लोगों को थिकनेस ऑफ डबल लेयर पर डिपेंड है. हाँ, so whatever this model is there, this model is known as Gouy-Chapman model. Which model? Gouy-Chapman model. And now whatever this Gouy-Chapman model is there, this after we want to learn a Stern layer. Which model? Stern layer or Stern model. That we will look towards. But again, to explain this Gouy-Chapman model, I'm introducing with you one to two slides to clarify your Gouy-Chapman model. Just wait till then, I'm loading this slide. Are you guys clear with are you guys roughly clear with what is mean by Gouy-Chapman model? Please tell me in chat box. If yes, then tell me like yes by typing yes, and if not, then tell me by typing no, so that I can again repeat it. So now, oh, whatever this Gouy-Chapman model is there, this Gouy-Chapman model is having their counter ions, is having its counter ion. And now whatever this, okay, if you're clear, then that's good, very good. So now whatever this Gouy-Chapman model is there, na, this Gouy-Chapman model is having simply the kinetic energy, simply the kinetic energy of your counter ion you can look towards, or you can check it out. But whatever this kinetic energy of your counter ion is there, counter ion means what? अगर से आपका इलेक्ट्रोड, अच्छे से सुनो हाँ सब लोग, अगर आप नेगेटिव इलेक्ट्रोड कंसीडर कर रहे हो तो उसका काउंटर आयन क्या होगा बेटा? पॉजिटिव. तो अब ये जो कुछ भी पॉजिटिव आयन्स होंगे वो थोड़े अपार्ट को, मतलब थोड़े जैसे कि हम हेल्महोल्ट्ज मॉडल में पास पास में ले रहे थे, वैसे गॉय-चैपमैन मॉडल में होता है क्या? बिल्कुल भी नहीं. तो अब ये जो कुछ भी Gouy-Chapman model, whatever this Gouy-Chapman model is there, in this model you are having counter ions, and whatever these counter ions are there, these counter ions kinetic energy is having the effect onto the thickness of your onto the thickness of your diffused double layer. मतलब क्या? अब ये देखो यहाँ पर अगर से आपका पहला स्टेशनरी फेज ही दूर, स्टेशनरी लेयर ही दूर हो रहा है, तो मुझे बोलो आपका डिफ्यूज्ड जो कुछ भी आयन्स होंगे वो तो और दूर होंगे। तो मुझे बोलो डिफ्यूज डबल लेयर विल बी वेरी, इट्स थिकनेस विल बी लार्जर वन और स्मॉलर वन? ऑब्वियसली लार्जर वन। अब ये जो कुछ भी थिकनेस हो गया आपके डिफ्यूज्ड डबल लेयर की, तो दिस थिकनेस इज डिपेंडेंट ऑन टू द चार्जेस ऑफ योर concentration of your counter ion. ये किस पर डिपेंड होगी बेटा? Charges of your these counter ions, charges of your these counter ions, and whatever these charges are there na, about your counter ions, these charges, these these can be explained on which thing, and that thing or that distribution is known as a very famous distribution. It is for your models or for your particles. In our statistical thermodynamics we are learning this very famous one model, whose name is nothing but Boltzmann distribution, whose name is nothing but Boltzmann distribution. And whatever this Boltzmann distribution, now I'm not going into the much detail of that derivation and equation, because here we are not expected to derive what is mean by Boltzmann distribution equation and all. Directly I'm showing you whatever the Boltzmann distribution level, Boltzmann distribution equation is. So whatever this Boltzmann distribution equation is there, it is right in front of you. I have boxed it by the red color box, and whatever this your Boltzmann distribution is there, that Boltzmann distribution law or Boltzmann distribution equation is n is equals to n0 into exponential raised to exponential raised to minus z e psi upon kt, where whatever the your n0 means what, z means what, e means what, k means what, everything we have represented here. Likewise, n0 means your bulk concentration, z means the charge, as you know very well, e means the charge on your proton, and k means Boltzmann constant, obviously. And what is mean by psi? Because now from this class onwards, because we are at the end of our electrochemistry topic, for whatever for our syllabus it is. So see, whatever this your Boltzmann psi is there, this psi is nothing but a potential difference here. But whatever this psi is there, this psi again we are using in our quantum chemistry. What is mean by psi? Every time you will learn psi. It is not psi means like दुधावरची साय, huh? I'm just part of joke, थोडासा हसावं म्हणून, bad joke I know, but see, whatever this psi is there, this psi is nothing but a wave function. What is that beta? Psi is nothing but a wave function. But here we are representing this psi is not, here we are representing this psi as what? For potential difference. So please do not confuse here psi and that one our quantum psi. And now whatever this Boltzmann distribution is, the Boltzmann distribution equation is there, this you can combine with Poisson equation and you can get the thickness of the double layer. But see guys, let me tell you one thing. There is means they are not expecting for guys to explain to derive each and every equation. If you put this Boltzmann distribution equation in Poisson equation, then it will give you simply the thickness of your double layer, and it is right in front of you, lambda, right in front of you. And what is that? Lambda dl, and it is equals to it is equals to, in this box we have mentioned. And now you may ask me, ma'am, is it important? Can they ask us a question? So see, we can tell, we can just discuss what is that, but we can't predict on which point they can ask you a MCQ. We can just predict what type of MCQs they can ask. Yes ना? So अब ये जो कुछ भी Gouy-Chapman model है, now we will learn about whatever this Gouy-Chapman model is there, is it having any limitations or is it having any drawbacks? Limitations म्हणू आपण, drawback म्हणण्यापेक्षा limitation. So its answer is yes. Again, sorry for the disturbance. See, लिमिटेशंस फॉर गॉय-चैपमन मॉडल और जीसी मॉडल भी, वो जीसी मॉडल से भी पूछ सकते हैं, हाँ, आपको तो कंफ्यूज नहीं होना है. सो दिस मॉडल इज फेल, this model is fails to explain the reality of including ion-ion interaction. You see, what is mean by ion-ion interaction? See, whenever we are having this solvent, solute, their solution, and their interaction of different ions, and their interaction of different ions, this is known as ion-ion interaction. This is known as ion-ion interaction. And now here we are discussing, or here we do not have any proper explanation for ion-ion interaction by using this model, and that is why this is the limitation of Gouy-Chapman model. And now this is nothing but the assumption for your point charge ions. Point charge ions means what? Those ions, whatever the properties are there, those were not predicted clearly. And now the third and fourth limitation is right in front of you. And what is that? It comes to the value of dielectric constant. Dielectric constant, and which was taken as a constant in the region between the electrode and it's a bulk solution. एंड दिस इज नथिंग बट द लिमिटेशन. मतलब क्या? अब ये जब कभी भी आप कंसिडर करते हो इलेक्ट्रोड एंड उसके बल्क सॉल्यूशन में, तब आपको उस सॉल्यूशन का डाइलेक्ट्रिक कांस्टेंट क्या है, कैसे है, ये सब कुछ पता होना बहुत जरूरी होता है. बट यहाँ पर ये गॉय-चैपमन मॉडल आपको एक्सप्लेन कर पाया क्या? नहीं. और एक आपका क्या बोलते हैं हम, एक लिमिटेशन है, एंड दैट इज नथिंग बट इट मे नॉट बी एबल टू reproduce the capacitance potential curves in the region beyond he PZC proximity. See, this is not expected to learn each and every limitation in detail. Just you have to know these limitations. Okay. Hello, hello, am I audible to everyone?
Yes, ma'am.
Yeah. Okay. So after this Gouy-Chapman model, okay, before going towards anything or before I skip anything, let me just show you one slide to explain you a Gouy-Chapman model again. Means कैसे वो differences होते हैं, कैसे वो distances होते हैं, बताती हूँ. Gouy-Chapman. Gouy. Okay. Electro. Hmm. Wait a minute. Let me check. Hmm. These are nothing but the limitations of Helmholtz Perrin double layer model. Uh, I think I forgot to show you. I forgot to share with you. Just read it out. Just pause the recording and you can check these limitations. These are again important. Now I'm trying to share with you. Hmm, Just read it out. Mm, hold. Hmm. इसी से बताने की कोशिश करती हूँ. वो जो परफेक्ट स्लाइड है वो मिल नहीं रही है अभी मुझे. हम्म, 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 इसकी हेल्प से बताती हूँ, हाँ? अभी वो स्लाइड मिल नहीं रही है. इट इज मिसिंग समवेयर. सो अब ये जो आपका इलेक्ट्रिकल इसी पर से समझाने की कोशिश। ये और आपका ये जो स्टेशनरी ये दो लेयर्स है ना, ये दूर दूर होते हैं, ऐसे दूर होते हैं। एंड इसी को हम, इन्हीं लेयर्स के बीच में जो कुछ भी आपको ये मॉडल है, तो इसी मॉडल को हम बोलते हैं गॉय चैपमैन मॉडल। आई थिंक गॉय चैपमैन मॉडल इज प्रिटी क्लियर टू everyone. If yes, then type yes in chat box, and if no, then please type no in chat box so that I can explain you again. Yes or no, yes or no. And after this quite Chapman model, are you guys clear? Slide ಕೊಟ್ಟಿದ್ದೀನಿ.
मध्ये
Hmm. Yes, भेटली मला स्लाइड. ही स्लाइड होती ती, मला जी दाखवायची होती ना तुम्हाला ती. येस, आय गॉट इट. म्हटलं होतं ना माझ्याकडे आहे भेटत नाही वेळेला. Yes. So, Gouy Chapman model, Gouy and Chapman, both of the scientists in the year 1910 and 13 में उन्होंने क्या बोला था हमें, सब कुछ अब तो पढ़ना हो गया है, समराइज करती हूँ 1 मिनट में. एक मतलब अब 1 मिनट. हाँ, तो अब ये जो कुछ गॉय एंड चैपमैन है ना, इन दोनों ने क्या बोला था हमने इस हेल्महोल्ट्ज मॉडेल में, की ये मॉडेल के अगदी म्हणजे या मॉडेलच्या अगदी जवळ दुसरा लेअर असतो. येस और नो. This model के अगदी sorry, this model is having its electrode as a negative. If you are considering as a negative, you can consider anyone electrode as a positive or negative. With reference to that, your surrounding ions will change. And now, whatever, see the difference in Gouy-Chapman model, it is higher one. It is higher one. But if you look towards this difference in Helmholtz model, it is a lesser one difference. And what happened when this difference is getting increased at that time, whatever their ion interaction is there, that the formation of diffuse double layer will get increased, when their distance will get increased, I mean to say their thickness of their ions will get increased obviously. And whatever this model is there, this model is simply having the limitation which we have explained just now. Now, please tell me, are you clear with this? Yes or no?
Yes.
Okay, very good. Now, we'll start to our next model.